Hello students, in today's video we will discuss process scheduling. Now before starting with the process scheduling concepts, we will revise certain basic terms which will be frequently required in understanding process scheduling. Then we will see process scheduling criteria, and then we will solve numericals based on some scheduling algorithms. Now these are the basic terms or basic concepts which are frequently used in operating system. So let's see process. So we already know that process is nothing but it is a program in execution. It is different from program, whereas a program is nothing but it is a set of instruction and it is a static entity, whereas process is a dynamic entity. Then we have seen the process states. So this process from goes through various stages. So different process states we have seen. So process state is nothing but like as a process executes, it changes its state. The state of a process is defined as the current activity of the process, and process can have different stages, or the 5 states which we normally show with the process state transition diagram. Let's have a look at this. So we know that whenever a process is ready for execution, whenever all resources are available with it, it is admitted to ready queue. Then whenever CPU time can be given to a particular process, it will be dispatched to the running state. So this oval shapes are nothing but these are the states of a process. Then this running process may go to wait state if it requires to perform certain IO operation. Then after its IO completion, it again goes to ready states. Then after completion of its execution, that running process may be terminated. So these are the 5 main process states. Now let's look at this scheduling criteria. There are many different criteria to check when considering the best scheduling algorithm. Let's see one by one these criteria. CPU utilization. To make out of the best use of CPU and not to waste any CPU cycle, CPU would be working most of the time. Ideally, we expect that CPU should be working for 100% of the time. But considering the real system, CPU usage should range from 40% for light loaded systems to 90% for heavy loaded system. Now next point is the throughput. The throughput is nothing but it is the total number of processes completed per unit time, or rather say total amount of work done in unit of time. This may range from 10 processes per second to 1 per hour depending on the specific process. Then we have the third criteria as a turnaround time. It is the amount of time taken to execute a particular process. That is the interval from time of submission of the process to the time of completion of the process. Now next criteria is the waiting time. The waiting time is the sum of the periods spent in waiting in ready queue. Amount of time a process has been waiting in the ready queue to acquire the control of the CPU. The next one is the load average. Load average is the average number of processes residing in the ready queue waiting for their turn to get into the CPU. And then we have the last criteria as the response time. Response time is the amount of time it takes from when a request was submitted until the first response is produced. Now students, please remember it is the time till first response and not the completion of process execution. So in general, CPU utilization and throughput are maximized. These two criteria we try to maximize through with the help of the scheduling algorithm, and other factors are reduced for proper optimization. Now CPU scheduling. Okay, so like first question arises, like why scheduling is required, why we need scheduling. So as we know that in multi-programming environment we want the maximum utilization of the CPU time. So whenever CPU is idle, the operating system must select one of the process from its ready queue for execution, and this selection procedure is carried out by the scheduler. Now the CPU scheduling decisions may take place when a process through this CPU scheduling decisions may take place when a process switches from running to wait state. So here a scheduler will play its role. Then when process switches from running to ready queue, so a process will switch from running to ready queue whenever it encounters an interrupt. Then next is whenever a process switches from wait state to ready queue. So here, so after its IO completion, it will come out of this wait state and it will switch to ready state. And the last is whenever process completes its execution, it will be terminated. So again, scheduler will play its role here. Now this first and fourth criteria, scheduling under these two criteria are non-preemptive, whereas other schedulings are preemptive. So non-preemptive means once CPU started its execution, it cannot be interrupted in between, and preemptive means it can handle other interrupts and it can be interrupted in between. Now let's talk about this types of schedulers. In short, so basically schedulers are classified as a short-term scheduler, medium-term scheduler and long-term scheduler. Now as the name suggests, short-term and long-term. So we can say that the short-term scheduler means it is a kind of scheduler which takes decision very fast. It schedules very fast. So obviously this algorithm will be less complex. So normally this is also called as a dispatcher. So this short-term schedulers, they decides which of the process from ready queue is to be executed. Long-term scheduler, yes, as the name suggests, it is the complex algorithm which takes the comparatively large amount of time to make the decisions, and it decides which jobs or processes are to be admitted to ready queue. And then we have this medium-term scheduler, which temporarily removes process from main memory and places in secondary memory. Now we will see this scheduling algorithms one by one. So we have this first method, first come first serve. As the name suggests, the CPU time will be allocated to the process which arrives first. It is similar to as a FIFO.